Welcome to the MecSoft User Spotlight series, where you can find real users using MecSoft products. Today we'll be spotlighting DeLaRue Authentication Solutions and their use of VisualCam C for OnShape. Authentication Solutions, located in Logan, Utah, is a wholly owned subsidiary of DeLaRue, a UK-based global company that provides governments and commercial organizations with the products and services that underpin the integrity of trade, personal identity, and the movement of goods. The facility in Logan, Utah manufactures anti-counterfeiting and authentication appliques to exact customer specifications. An authentication solution is a physical pressure-sensitive label that is applied to a company's product or packaging during the manufacturing process that alerts the consumer that the product they are looking at is authentic. The label can consist of holographic imaging, as well as serialization and barcoding that allows the customer to perform a track and trace of their product. These labels are not embossed. They are the result of extensive development of the DeLaRue proprietary laser imaging process, all performed within a 1/1000th of an inch thickness of photopolymer. The product packaging would include instructions on how the label should appear to the human eye. A simplified digital sample of an authentication label is shown here for discussion purposes. John Humphreys is the engineering manager and has been with DeLaRue Authentication Solutions for 18 years. Because authentication is a relatively niche market, there are no OEM manufactured systems that can produce these authentication labels. The entire manufacturing apparatus is a unique and guarded proprietary process that is tailored to each customer's authentication solution needs. We recently sat down with John to discuss his use of VisualCam C for OnShape as his computer-aided manufacturing solution of choice for DeLaRue's machining design and prototyping. John, like all experienced designers and engineers today, has been using desktop CAD design software tools since they were first introduced. His computer-aided design CAD system of choice for years has always been SolidWorks. His computer-aided manufacturing CAM system of choice has always been VisualCam for SolidWorks. We say has been because John has also been using the OnShape cloud-based CAD system since its launch in 2012 and has also been using VisualCam C, the full cloud production CAM solution for OnShape during its beta release and then production release in 2018. John relies on 4 different CNC machines on a day-to-day basis. The MecSoft technical support staff worked with John to fine-tune VisualCam post-processors for each of his manufacturing centers using VisualCam's built-in post-processor generator. The machining hardware and service at DeLaRue Authentication Solutions includes the Roland MDX 540 milling machine for plastics, the CNC Master Supra knee mill milling machine for aluminum, and the X-Carve CNC router for wood and plastics, as well as a custom-built CNC router for woods and plastics. We asked John what drew him to OnShape's cloud-based CAD solutions. Here is John's short list of reasons. The future is on the cloud. The software industry in general is going cloud-based, and John feels that OnShape is on the cutting edge of that migration for the CAD industry. The OnShape development team. John was comfortable in knowing that the same team that initially developed SolidWorks is now developing the OnShape platform. Updates and compatibility. John doesn't have to pay an IT group to come in and update their software. OnShape updates occur automatically every 3 weeks. John can also access his OnShape designs from any computer anywhere in the world without worrying about hardware compatibility. Collaboration. John can collaborate and share design information with colleagues and contractors who do not need a paid OnShape account to view them. An early concern John had when migrating to OnShape was his ability to generate the G-code he needs to run his multiple CNC machines. CAM was the very first OnShape add-on application that John started looking for. John also expressed these added benefits of using Visual CAM-C for OnShape. OnShape compatibility. Visual CAM-C is a fully integrated OnShape partner plugin. Other CAM solutions require you to download and translate part models on your desktop computer, breaking the link with the OnShape part. With Visual CAM-C, toolpaths are updated automatically when the OnShape part model changes. Accessibility. John can use the same OnShape account with Visual CAM-C at work and at home, generating G-code for all of his CNC machines at any time and from anywhere. Minimum learning curve. John has been using the desktop version of Visual CAM inside of SolidWorks for many years. This made the transition to Visual CAM-C much easier because many of the same features are now available in Visual CAM-C for OnShape. John has agreed to share a small sample of how he uses Visual CAM-C for OnShape. The inspection light mechanism shown here is a typical machine design subassembly that incorporates multiple components that require CAM G-code to machine. The DeLaRue production system incorporates multiple stages, each stage being a production process that can incorporate as many as 100 or more machine components. The parts and assemblies are displayed and worked on in the Part Studio tab of the OnShape document. Toolpaths are generated and displayed in a separate but associated Visual CAM-C tab within the same OnShape document. When design changes are made in the Part Studio, the associated Visual CAM-C toolpaths are updated automatically. Here is more of what John had to say about Visual CAM-C.
I think OnShape is on the cutting edge of the CAD industry. A real concern is, am I going to have the ability to do toolpaths and create my my code for my machines with a cloud-based software? And that was the first thing I started looking for, was some type of a CAM-CAD program that would work with that. And most of them were just desktop ones where you download a model, and it really wasn't a true cloud-based. And when MecSoft started working on that, I thought, well, that's great, because I'm already familiar in using the visual mill. I'm looking to this year to push more and more onto OnShape. I'm anticipating that probably this year we may cut the cord with SolidWorks as far as the yearly license subscription.
Right. Thanks, John. One of the components in the inspection light subassembly is shown here. It contains many prismatic features that were machined using 2.5-axis toolpath strategies on the DeLaRue CNC Masters Supra knee mill machining center. The features include drilled holes of various sizes and depths, blind pockets, open slots, and more. These features are shown in the Part Studio tab and in the corresponding Visual CAM-C tab, both within the OnShape document. The stock is 1/4 inch aluminum plate, measuring 13 inches by 1 inch. On the left, we see the contents of the Visual CAM-C Machining Job tab. It defines the machine tool orientation in relation to the OnShape World Coordinate System, or WCS. This is followed by the post and stock definitions. The setup defines the orientation of the Machine Tool Coordinate System, or MCS, for the machining operations contained within it. The Work Zero defines the machine zero location point from which all toolpath coordinates are measured from. This is then followed by the various drilling, pocketing, and profiling toolpath operations. You see that moving the cursor over an operation in the machining job displays information about that operation, such as its name, cutting tool, cut feed rate, estimated machining time, and more. On the right, we see the Tools tab containing an assortment of drill and mill tools located within the document. Tools can also be saved and reused from a tool library. Drilling and hole making. Shown here in the left side image, the component requires through holes of 4 different diameters. Each are defined as deep drill operations with a specified step increment. This means that the drill will cut to each increment depth, retract, and re-engage until the full depth is obtained, similar to peck drilling. A minimum distance sorting rule is also applied to minimize machining time. The 0.107 diameter holes are shown here. 2.5 axis pocketing. Shown on the right, a 9.57 by 0.4 pocket runs nearly the full length of the component at a depth of 0.135. The pocket is cut in 3 levels using a 1/8 inch flat end mill and a 35% step over. A 10-degree ramp entry motion is used along with a 45-degree linear exit retract motion. The sidewalls are cut with 0 stock remaining, leaving a .063 radius in the 4 corners. 2.5 axis slot profiling. To cut the 0.7 wide by 0.13 deep open slot shown here in the left side image, 2 profiling operations are used that follow each side of the slot. Notice that the engage and retract motions shown in magenta and white are linear and set to 0 degrees. This extends the toolpath out past the open slot at each end for each of the 3 cut levels. The cyan paths are linear motions, while the dark blue paths are arc motions. The entry motion is yellow, while the approach and transfer motions are in red. 2.5 axis hole profiling. To cut the counterbore hole shown on the right, a profiling operation is used, again with the same 1/8 inch end mill. A 10-degree ramp entry creates a helical motion, shown in magenta, to the first of 3 cut levels. Depth first cut levels ordering ensures that 1 complete counterbore is cut before moving on to the next. Shown here is some sample G-code generated for the 2.5 axis pocketing toolpath. The G-code was generated within the OnShape document for the CNC Masters Supra knee mill using the VisualCAM-C CNC Masters Inch post-processor, and then automatically downloaded to John's local computer. This is one of over 300 post-processors included free of charge within VisualCAM-C. These are the same posts that have undergone years of user-tested reliability in MecSoft's desktop VisualCAM application. John estimates that they have approximately 10,000 components that have been designed and machined using VisualCAM for SolidWorks. Today, about 25% of the new CAD design and CAM programming is performed in OnShape and VisualCAM-C. John expects that will increase to nearly 100% in 2019 as they migrate over to OnShape. We would like to extend a special thanks to John Humphreys and DeLaRue Authentication Solutions for allowing us to showcase their work. To learn more about DeLaRue Authentication Solutions, we invite you to visit them online, on Twitter, and on LinkedIn. For more information about VisualCAM-C, we invite you to visit the VisualCAM-C product page and learn more from the MecSoft Tech blog. To learn more about the OnShape cloud-based CAD solution, we invite you to visit them at onshape.com or read more in the OnShape CAD blog. Here is a features list of what you can find in VisualCAM-C, the production CAM solution for OnShape users. This video was brought to you by MecSoft Corporation, your CAM partner.